So this is a sample bug. I'm still not sure where you should consider the problem to lie, whether it's in my test case or in IntelliJ code. It could probably be fixed in either, but basically it's an intermittent hang in one of our headless tests, which extends debugger test case, and it only happens. It's really intermittent. Only happens about once in every 10 to 20 runs, and a hang occurs at the end of the test, and we see this log output. So you see the teardown there, and you see there's a 5-minute gap, and then there's some sort of timeout happened. The test itself hangs forever; it never comes back. So that's why I was quite keen to get to the bottom of it. So the approach I took to try and figure this out was to use the undo LR API. So the thing that Chris showed you just now recorded the entire process from start to finish. With this API, Java API, you can turn on and turn off recording. So you can start recording where you think there's a problem, and stop and save recording at the end. So the approach was to obtain a good recording when it works and save that, and then keep running a test until the hang occurred, and then save the resulting recording as the bad recording, and then compare the behavior. So a recording, as Chris just explained, appears to IntelliJ to just be a remote JVM debug target, which we call the bridge. So normal JWP commands work the same. IntelliJ doesn't know the difference, and the plugin reverse operations piggyback off JWP create string to, for example, inform the bridge that the next single step should be interpreted as a reverse single step. So when you press reverse single step, it's actually sending an initial command using create string, and then it's doing a normal single step, and except that it's going backwards in the bridge. So we modified the code in the test. So we've got our session paused method here at the end of the test, and we're starting recorded there. And then we've got our teardown thing, which is the thing you saw just now, which gets called after 5 minutes, and we save the test. We save the recording, and there's our run IDE thing in the build script to specify the JVM args to make all this happen. Okay, let's switch to IntelliJ. So I've got the recordings loaded. So I've got 2 sessions here. One's labeled good, one's labeled bad, and they're both connected to remote debug sessions with the recordings. So with the bad recording, I'm going to go to the end first of all. So I'm going to click on end. This is a bookmark thing here, by the way. You can add bookmarks of places of interest, but I'm just going to click on end, and that's going to take me to the end of the recording. Now that I'm at the end, I've set a breakpoint in teardown, so I'm going to go back to that. Okay, so here we are in teardown, and if we look at the caller here of what's called teardown, we can see that there's an exception being thrown, a runtime exception's been thrown. So that's interesting. Why has that happened? So we want to know why that's happened. So I've got a breakpoint further up, as you can see. So I'll go back to that. And I've also set a breakpoint on the runtime exception itself. So I'll go back to that. And as you can see, we've caught an interrupted exception. In the parent here, we can see at line 212, that's the log message that we saw. The test was running for over blah seconds interrupted, and we can see that something must have done thread.interrupt to interrupt it. So next question is why? Why has this happened? Why didn't the semaphore wake up? Because you can see we're in a loop here waiting for the semaphore to be released, but that didn't happen. So we've got a breakpoint where a semaphore is released just there. Now we can switch to the good recording. So again, we'll go to the end. And then we'll do the same thing. Go back. Error and teardown. As you can see from the parent, there's no exception being thrown there. So we go back again. And releasing the semaphore, which is fine. That's what should happen. So why? So we've got command cancelled. That was called from notify cancelled. And that in turn was called because we failed to schedule something. So we failed to schedule it, and we called notify cancelled. So that's interesting. So why does that scheduling happen in the one case and not in the other case? So we'll enable this breakpoint. And we'll go back. We'll go back to that. And then we'll step into it to find out exactly what is going on here. So then we'll step into the put on the event queue. Okay, so this is doing the put on the event queue. Come down here, and we're returning false because the queue has been closed, because the event queue has been closed. Let's compare it with what happens with the bad case. So go back. I'll step in. Step over that. Step over that. Step into that. Step over that. Step over that. Oh yeah, so the event queue in the bad case is not closed. So that raises the question of how this event queue ever got to be closed. So let's go back to our good case where we know the event queue was closed. And we've got a breakpoint where it's closed. So now we could go back and find out how it got to be closed. So we'll get rid of this. Breakpoint because we don't need it anymore. By the way, you might see lots of unset, unenabled breakpoints. I ended up with a lot of breakpoints to figure all this stuff out because it's for me at least it was quite involved. Okay, so this is where the queue gets closed. So we appear to be doing this process VM death event as a result of receiving this VM disconnect event. So we've received this VM disconnect event, and so we've called process VM death event, which is closing the process, detaching, closing the event queue, etc., which is fine. And also notice that we are doing this all from the debugger manager thread. So where does VM disconnect event get created? So that's the next question to answer. So again, I've set a breakpoint in the initializer for VM disconnect event. So let's go back, and there it is. And we can see what's happened. So this is the end of the target VM reader thread. So the reader thread, which is reading from the JDI connection, it's trying to read a packet, and it's obviously failed because the connection has been closed, and it's going into some cleanup stuff, and it's basically closing the event queue. What happens in the bad case? Again, let's go backwards. So we still get the disconnect event in the bad case. Same reason. So far it's the same. But at this point, what is the debugger manager thread doing? The thing that actually ends up handling this. Let's go and have a look. And if we look down the stack, we can see that it's in a thing called process remaining. So process remaining is basically taking a copy of the event queue, just here. It's doing a my events.clear queue, so it's taking a copy of the event queue and then processing any remaining events. So the event that we just created, the VM disconnect that we just created, won't get put onto this, won't get seen by this debug manager. And if we look further up, we can see that this thread request is basically coming to its end, and it's in a filing loop, and it's just cleaning up after itself. So in the bad case, we're not going to see that event. So if we go to process remaining and we look at what it is, it's a worker thread request. It'd be good to know where the worker thread request came from. How did that get created? So I'll put a breakpoint where the worker thread request is created, and we go back. And we'll come to that later. So this is where the worker thread request gets created. And if we look at the stack, for that, I've got a breakpoint there where start new worker thread is called. So if I go back and turn to that, so that's the point at which the worker thread gets created. And my dispose is not yet set. So going forwards, that's okay. Go forwards again. You see that my dispose is set later. And now we come to where we potentially create another of these worker threads, but now the my dispose flag has been set, and so we don't do it. Let's compare that with what happens with a good recording. So I'll go back to the close call, and if we look further up in the stack of the dispose of the where it's doing the invoke thread, we can see that we can see the worker thread request that is handling this event, this process, this VM disconnected event. So this is the worker thread thing that's handling it. So let's just mark that. Let's just mark that, and we'll call it my thread request. And then we'll go backwards. There's the VM disconnect event. Note the dispose call there. But here's my thread request being created, and that's happened before the dispose was set, and that's why this worker thread was able to continue processing and basically process the event. So going forward again. As our dispose call. So where's dispose being called from? And would you believe it's being called from our code? So that's our bug. It's calling session.dispose, and this is causing a really subtle thread ordering side effect. So 90% of the time it's absolutely fine, but occasionally it causes things to happen in a different order, and so actually what I did was I tried deleting that line because it doesn't appear to be necessary. So I just deleted that line, and hey presto, the headless test never fails anymore. That fixed it. So that's the kind of deep dive really of that I wanted to show you. I could show you one or two other interesting things. If we go back to the log output, I just want to demonstrate how you can do the log jump. So let's take a copy of that. Let's take a copy of that that log message where it's reached the maximum pause count. So I go to bad, and I've got our log jump thing here, and the timestamp. And there we are. It's taken us straight to that log message, which is handy. I've got bookmarks as well, so we can go to the end of the recording, go back, and back again. Let's say we wanted to bookmark that particular location because it looks interesting. So add a bookmark there, and go back to where, say, the VM disconnect. Go back to where the VM disconnect event is called. Got a bookmark there, and then you could just click on these bookmarks to take you to where you want to be. And that's it, really.